Looking at section D, we're going to begin talking about Venn diagrams, and to me this is when it really starts getting fun because Venn diagrams are often used to represent the relationship between certain numbers, objects, or things, or in this case we'll call them elements. Venn diagrams were initially invented or used by a guy named John Venn, and they consist of a couple of different things. The first thing is they're going to always have a universal set, which we said is represented with a capital U. In this case, let's put some number values in between here, 2, 3, 5, 7, and 8. And the universal set is always represented by a rectangle. The subsets are usually represented then with circles. I suppose they don't have to be, but typically that's what you would use. So if I have set A, in this case let's put it in a different color. So if I have set A, and this includes the numbers 2, 7, and 8, well, all of these numbers are within the universal set, so it makes sense that I would represent set A as being inside of set U. Now, if I was putting everything in here, so let's start labeling things. 2, 7, and 8, they're members of A, so I'm done with that. Now let's see, whatever is left over, these are going to be members of just set U. So let's put them out here in set U. Oops, I put 2 in the wrong spot, huh? Okay. So 2 should just go in here with the A. Okay, so now 3, 5, and that's it. Those are the two numbers that will be just in set U. So a couple of things I could note here. The complement then of A, this is all A right here, this section. So everything that is not A would be the complement of A. So this is the complement of A. So I would say that the complement of A is the numbers 3 and 5. Now looking at subsets, if I wanted to say that set B is a subset of A, remember that means that everything that is in B is also in A. So on a Venn diagram, this would be my universal set, and let's say this is set A, and remember everything in B is also in A, so B might look like this, and here's everything in B, which is also within A, and A is also within the universal set. So if I want to put some numbers to that, let's look at how that would pan out. So let's say U equals, in this case, just integers, positive integers 1 through 5. And then let's come in here and say that A equals the numbers 1, 2, 3. Okay, and now let's go one more step and let's say that set B is the number 1. Well, let's check this out and see if this is a true case. B is a subset of A. That means everything in B is also in A. Well, that's true because the number 1 is in here. So let's draw our 1. Can't see that very well, so use a different color here. Okay. Now we're done with the number 1. It is finished. It's represented. So now out here in set A is just the number 2. Well, we're done with 2 now. So what's left is 3, and 3 is in A, so that's done. And now we can put 4 and 5 should be out here. And this would be the appropriate representation for this. Now, a couple of other things I want to show you here. Marking intersection and union and disjoint sets. First of all, let's do representation of an intersection. So here's my universal set, and then within that I have two subsets, set A and set B. Well, if I was going to shade the intersection, which would be noted like this, A intersect B, that would be this little football right here in the middle. Okay, because remember A intersect B translates as A and B. Everything in this section is in A because here's A. Everything in this section is also in B because here's B. Let's look at the union. Remember, we notate union with a capital U. So here it is, A union B, and my universal set, and here's my two subsets, A and B. Remember, we translate A, or union, excuse me, with or. Well, let's start over here. If I have the number that is in this section, which is just in A, is this in A or B? Yes, it is. So everything that's here is included. Well, what about here? If I put a number in here, is it in A or B? Yes, it happens to be in both A and B. So yeah, it counts. So this section is included. And then what about numbers here? Well, they're in A or B, they're in B. So the union of A and B is when we just kind of merge all of these together, and this whole thing is going to be the union of A and B. Now, mutually exclusive or disjoint sets would look something like this, where I have my universal set and I have two individual sets that have absolutely no elements or members in common. So if I was giving you an example of set A equals 1, 3, and 5, and then set B equals 2 and 4. Okay, I could put these on the Venn diagram if I wanted to, but you'll see very quickly that there's no overlap. There are no numbers that are in common between these two sets, so they're mutually they're disjoint or mutually exclusive sets. We would say that this is an empty set.